Okay, so I'm going to walk through creating a very simple Rails application, and I'm going to build up the components of the application piecewise, so I'm not going to use scaffolding. So I will begin by creating a new Rails app, and then I will create a model, and after that model I will create a controller. I will then create some routes that will allow URLs on our server to map to particular methods within my controller, and I will have the controller interact with the model. And lastly, I'll have the controller hand off some data to a view and have the view display that data. And I'll also be using Git along the way, and so I'll post the Git repository so you can see the sort of the incremental commits of the project. Hopefully the screencast works as well, so you could look at the screencast and reference what was up on the Git repository as well. The one thing that might be slightly different from what you were doing is I'm using Atom with a plugin that lets me edit files not through the shared folder, but by way of an SSH tunnel. And the reason I'm doing this is when we edit files directly on the Vagrant shared folder, the Rails server can't detect that they've changed, which means that every once in a while we will have to restart our Rails server, which is frustrating. It's frustrating knowing when you need to restart and when you don't. But if I edit by way of SSH, those edits are happening natively on the virtual machine, so the Rails server can detect those changes. So I'll, on my own time, make a separate little mini screencast on how to set Atom up to do this kind of remote editing. If you use an editor other than Atom, there'll be ways to set this up as well. So Sublime has remote editing capabilities either by way of a plugin. VS Code does as well. So you'll be able to take the settings that I use for this Atom plugin and apply them to your own editor, and that will sort of remove that pain of having to restart the server. Okay, where to begin? I've got Vagrant up and running here, and I've SSH'd in, and I will navigate to my Vagrant folder and to a Rails folder within there. I'm running Rails 5.1.4. I see that by running the Rails-V command, and so Rails is this command line tool as well as it's this curated list of gems. So we're going to be using the command line tool a lot when we're working with Rails. And the first thing we always do with any Rails project is use Rails new to create the project. So I'm going to make a Pokemon app. And so that will give me some ability to store Pokemon into a database is effectively what I'm going to do. So there's Rails new, a lot of output there. The gist of what's happened is if we scroll up to the top, a whole bunch of files and folders were created, and we'll take a few moments to look at some of the important files and directories that make up all Rails projects, which is initially overwhelming, but it's quite nice when you understand the layout of a Rails project. You can hop into existing Rails projects a lot easier than, say, hopping into a project that isn't part of an established framework, because everything's always, for the most part, in the same place. The other thing that the Rails new command does is it checks to see if you have the latest versions of all the dependent gems. So Rails is this collection of curated gems that makes web development sort of the Rails way. And all of those gems depend on other gems. So when you create a new project, it goes and checks to see if you have all the latest versions of the gems that match the version of Rails that you're using. And any that are listed in green, like Capybara here, it means it found a newer version of that gem, downloaded it, and installed it. And so I ran this yesterday, so most of my gems are at the most recent versions. The only one that was new was Capybara. If you haven't run Rails new in a while, it'll take a lot longer because it's going to have to download a lot more sort of latest version gems. And there I am. I'm now at this command prompt back in the Rails folder, and I can navigate to that Pokemon Go folder. We can see a few things here. It might be easier just to see them by way of like Windows File Explorer, so I'll sort of File Explorer over to that folder. Most of what we're going to be doing today is going to happen in 3 main folders: the app folder, the config folder, and the DB folder. The app folder, as the name says, is where your application or most of your application lives. So this is where you will be editing your controllers and your models and your views. The config folder is where you set up configuration data, and most of the config data is set to defaults, sane defaults that should just work for most Rails projects, but we will be editing the routes file here to define how URLs are interpreted by Rails and which controller actions get executed when particular URLs get sent to our Rails server. And then in the DB folder, that's where our database is going to live. Currently, it just has a single file in it, but there's going to be this is going to be where the SQLite 3 database is going to exist, because we're going to just stick with using Rails in its default mode, where it uses SQLite 3 for its persistence. You can also see that there's already in my folder a .git folder, which means that Rails just assumes that you're going to use the Git version control system, and it makes it so that you don't have to run git init on the folder. And so if I go to my folder and I type git status, it'll tell me that there are untracked files and folders, but it's already a Git repository. It just doesn't have anything checked into it. So I can run my first git add and git commit. So add dot's going to recursively add all of the files and folders there. Initial commit of a new Rails app will be my first commit message.
Did it create a git ignore?
It did. So it created a git ignore, which is something I did not cover when we looked at Git, but we can see that. Let me just refresh here. Git ignore is a file that defines all the things that you wish Git to ignore. And so, for example, by default, Git is told to ignore our SQLite 3 databases so that we're not committing the full database to our repository. It also ignores all the log files in the log folder and the temp files in the temp folder. So it's sort of set up to ignore the right things. You can also add your own things that you wish it to ignore, or you can, if you really wanted to keep your SQLite database in your repo, you could, remove those lines, or at least this line 11 here from the file. Okay, so most of the work that we do with Rails, we just are going to bounce back and forth from the command prompt to our editor. So the command prompt, we're typing Rails commands and having Rails generate files and folders for us. And so we're going to start by having Rails generate a model for us. So I could type Rails generate if I wanted to, but there's always a short form for all the Rails commands. So Rails G is going to be our generate command. And I want to generate a model. And I want to generate a model for a Pokemon, and I'm going to keep my Pokemon simple. It's just going to be a name and some hit points. And so we can add other attributes to our model at a later date. So I'll just do just 2 of these things for now. The created at and the updated at columns that are going to be in the database, those are created for us automatically. So we don't have to worry about defining those here. It's just, as well as the primary key, the ID primary key is also going to be created automatically for us. Run that. And like with Rails new, it's going to sort of show us which files and folders it's created. So there is a db migrate long timestamp create pokemons.rb. There is a app models pokemon.rb. That is the model itself. So this migration here is how the table ends up being created. So when you're working on a database-backed application, specifically if you're working on a database application that is where you're working with a team of people, making changes to the database over time and keeping the entire team up to date with those changes can be a little tricky. And so Rails has these things called migrations that capture your changes that you're making to the database over time as code, and then you check those into your repository, and then as the team sort of resynchronizes with the repository, they can run these migrations, and then everybody on the team will have a database that's in the same state. It also allows us to, if we ever need to roll back to a previous version of the code, we can also roll our database back to what it looked like at the time that code was written. So it's a way of versioning our database using Git. So we'll look at that file first, and then we'll hop over to look at the model. So the DB folder now has this migrate subfolder, and within it, it has this migration. It starts with a really long timestamp. That's just to prevent the one out of a million chance that you're working with a team member that happens to create the same named migration as you. And so there would normally be a collision if that occurred. And in this case, the collision should be mitigated because it timestamps it right down to like the second or something. Yeah?
Are you able to edit the pluralization?
Yes, so notice that, Michael has noticed that the plural of Pokemon is Pokemon, right? And now we've been told that the plural of Pokemon according to Rails is Pokemons. You can do that. You can update that, but we'll leave it for now. But yeah, you can always tell Rails sort of custom pluralizations. This is something here that will not be visible to the outside world, so we can feel comfortable, and also like sticking with Rails conventions is usually the safest idea. But yeah, if it bothers you, you could always, before running that migration, define that custom pluralization. You can see here we have a class called create Pokemons, and it inherits from something called active record migration, and has a single change method in it that creates a table. So our table will be called Pokemons. That is the Rails convention to have your the noun that you're saving pluralized in the table name. And then these are the two things we define for the attributes of a Pokemon, a name and hit points, which is a string and an integer. And these are our created at and updated at timestamps. Over in the app models folder, we can see the Pokemon RB. It's a class called Pokemon that inherits from something called application record. Application record is just sitting in the same folder, and it's a class that inherits from active record base. So that's where we get all of our active record magic from. The reason we have this sort of middle class is that we can put things into this application record class that will then be inherited by all of our models. So it's just a way of letting us hook into that inheritance chain. If we ever want something that all of our models' behavior or state that all of our models need access to, we can put it into application record. But really, it's just getting us to here, inheriting from active record base. So just having this migration file doesn't make the database come into existence. I have to run my migrations, and I do so from the command prompt. Rails db migrate runs the migrate task of the db type, and so I run that. And the conventions for Rails are set up so that my database is just going to be created for me. It'll be of type SQLite 3. It'll be in the DB folder. And so if I went and looked at that DB folder, there's now a development, because I'm in development mode, .SQLite 3. And you can see that create table worked. If I run my migration again, it's just not going to do anything. So Rails keeps track of which migrations have been executed, and so it won't repeat itself in terms of sort of rerunning migrations. So there's some untracked files now that I can add by way of Git. in the DB folder, if I refresh it, there's also now a schema.rb. This is a Ruby file that contains all the create table statements for your entire database. So if you ever want to know what all the tables are and all the properties of those tables, you can look in this file, and it's the latest version of your schema as code. And so I currently just have a single table, and it has these columns. The only column that's not mentioned is the primary key, which is always called ID. But you can see the timestamp ones are present now. There's also a lovely gem called Railroady, which will parse this schema RB file and draw ERD-ish diagrams for you. So that can be a really nice thing if you're coming onto a new established Rails project and you want a view of what the database looks like as a diagram. You can bring in that Railroady gem and have it generate the ERD for you. The diagram at the bottom of assignment 2, that was generated in that manner. So it's not a perfect UML ERD, but it's a pretty good, way of visualizing the existing schema of an application. Okay, so I now have a table and I have a model. I can do a few things that are just going to be testing out if my Rails application is working. So one of them is to run the Rails server. So I can run Rails server. In the notes that you were working through, it probably asked you to go to /bin/Rails. So there is a bin folder here. The reason you would specify bin is that if you were doing Rails work in industry, you might be working with multiple projects where some of those projects had different versions of Rails. And so this is, by going to /bin, you're always going to get the version of Rails that matches that project, so what you used when you originally created that project. Because we are just working on, the version of Rails likely won't change while we're through this course, or it might change by a point release. So we can just run Rails. It's better practice to do /bin Rails. Rails server, or short form, Rails S. When we initially configured Vagrant at the beginning of this course, we set it up to forward port 3000 from our host machine to the virtual machine. That's because 3000 is the standard port where the Rails server runs. So if you think back to Web Development 2, we were working with Apache as our server, and we would run Apache once and it would serve up like any PHP file within our htdocs folder. With Rails, Puma is our server, and we run it per project. So if you're running multiple projects, you could have multiple instances of Puma running, serving up different projects on different ports. But we'll typically just have one running. Port 3000 is where it lives. And so I can go to that, localhost, port 3000. And that just lets me know that the server is operational. Yay, you're on Rails. I'm going to leave this server up and running, and I will come back to my command prompt. So I have Commander running here. I can hit this plus button to create a new tab. That'll leave the server running over here. I can then navigate back to my Vagrant Rails within Windows and SSH back in. And I'm actually going to do that twice. I don't have to because I'm doing that tunneling. You do have to because of the fact that it's the way that Vagrant sets up its shared folders. So the edits that you're making are happening on the host machine, then they're being mirrored to the virtual machine, and then the server doesn't get those updates as to what files. So I'll make a small screencast on how to fix that up, because it is frustrating having to restart that server. So with both of these, I'm going to navigate to the folder in question. See Vagrant, Rails, Pokemon Go. Okay, so there you go. That's my server running on one. Over here, I'm going to run something else, which is the Rails console. Short form, Rails C. So I typically have 3 tabs up and running when I'm working on a Rails project, one for the server, one for this Rails console, and one for me to type in more Rails commands. If I'm doing test-driven development, I'll have another one, which is actively running my tests as I make changes. The Rails console is a version of IRB, that interactive Ruby prompt. So there's IRB, but it also has access to our Rails environment. So I can do things like ask for a count from my database, and it'll do a select count star from Pokemons. I can also do create statements here. So it'd be nice maybe to have some Pokemon data to work with. Pokemon.create, and I'm gonna create a name. I'm just gonna go in order. Bulbasaur, hit points, what, 45? So there is a Pokemon, so my count is now up to 1. I can create another Pokemon, Pokemon number 2, with 60 hit points. Moving up in the world. And then when I do Pokemon.count, I see 2, or I could do Pokemon.first and see Bulbasaur with its primary key, and it's updated at timestamps. So for Rails programmers, if you're used to, say, interacting with your database in a PHP environment with something like phpMyAdmin, the equivalent typically is just the Rails console, right? So that you're interacting by typing rather than by way of a web application. But anything you could do, no, that's not true. Often we're using phpMyAdmin to do things like create tables and edit tables for us. We never want to do any of that stuff manually ourselves when working with Rails. We always want to do that by way of migrations. And that'll come a bit later on in this course, how we use migrations to make updates to our database tables. Any questions that have come up while I've been chatting about Rails so far? Is there anything that's bothering you or that you need answered at this moment in time? So let's create a controller and then route to it, grab some data from the model, and display it in a view. And so this is, this is the image that I had drawn up on the board early on in the course. This idea of Rails being these series of boxes. So far, we've got our server up and running, and from the console, I was able to interact with my model and make modifications or queries to the database. But the rest of these boxes we haven't addressed yet. The idea that URLs get interpreted by a router, that the router maps those URLs to particular methods that are going to be executed inside of a controller, that the controller will then interact with our model, it will then hand data off to the view. That data can be embedded into the view by way of ERB, which is embedded Ruby, and then that view, which is a sort of a snippet of HTML, will then be embedded into an overarching HTML layout, which will then be served up by way of the server to the end user. So we have to do all those pieces now. We can't really do anything too sort of stepwise, because to see any output, we'll need to sort of link all of that together. I'm going to start by creating a controller. So again, I do that from the command line. Rails generate controller, and the name of my controller, I'm just going to call it home, and this is going to be like my home page. And so the name of my controller will be home. Often we might name the controller after what we are displaying, so you might call it Pokemon or something. I'm just going to call it home. Again, an output of the files that were created. The ones that are going to concern us are, we've got a home controller in the app controllers folder, and we now have a place for views associated with that controller to live in the app views home folder. The rest of these things here, there's some files associated with testing, some files associated with like creating little helper functions that we might use in the views or the controller, and then associated assets for styling or JavaScript functionality. We're only going to worry so much about this top stuff here today, the controller itself and its associated views. Okay. Refresh. Close some of my tabs up. I can come over to here, to my controllers folder. There is that home controller. It inherits from application controller, which is similar to what happened for our models. Application controller is in the same folder. It itself inherits from action controller base. And so this class is a place where we can put state or behavior that we want shared across all of our controllers. This is a common place that you might want to like inject, say, username or password authentication across your entire site. You might put it in there. So here we are, just a regular old class. In this class, we're going to create a method, and I'm going to call it index. This is it's a Rails convention, just like it's a convention for regular web development to have like an index.html or an index.php. Most controllers have an index action, and action is just going to be another name for a method within a controller. This is the index action. And after this action is executed, the associated view will be loaded, and that view is found in the app views home folder. The home here references the name of the controller, lowercased, and the file name is going to reference the name of the action. So it's going to be index.html.erb. In Rails, you will often see files that have double file extensions, and what the pattern here is the last file extension is what the file type is right now, and the first one is what file is being generated. And so in this case, this is an embedded Ruby file that will generate HTML. And embedded Ruby is going to feel very similar to the kind of templating we did in PHP, where we can echo data into an HTML page or loop over data and echo stuff out while performing that looping within HTML. Right now, I'm going to leave this index empty, and we'll add some functionality to it in a moment. I need this associated view to exist. And so from my command prompt here, I could touch that file, app, views, home, index.html.erb, and I can go to that folder. Welcome to our Pokedex. This is a paragraph. So notice this is not a fully formed HTML document. This is just a snippet of HTML that is then going to be injected into my layout. The application layout, or at least the default one, is found in the Views Layouts folder. And so it's right here. It's a pretty standard yet short HTML5 document. The key aspect of it is right here. This yield is where views get injected. I can also use this file as a place to put common HTML that I want to appear on every page. And so, for example, if I had a footer that I wanted to have at the bottom of every page, I could do that. And then all my views would have that at the bottom of them. So I have most of the pieces of the puzzle, the puzzle being this. I now have a controller, a view, a layout, a model. All that's left is the routing aspect of things. I need to interpret a URL and have that execute that index action, so then the view can be rendered. That means I need to edit yet another file. This time in my config folder, there is a routes.rb file. It has some data in it already, rails.application.routes.draw, and then it's a block, so a do-end block. And it says, for details on the DSL available in this file, see, and then it points you to the routing guide on Rails Guides. A DSL stands for a domain-specific language. This is something that's common in the Ruby world, where you use Ruby to make sort of a mini programming language that best matches the domain that you're working with, and then you use that mini programming language to solve the task at hand. And so the domain we're working with right now is routing. And so I can do things like, I would like to route the root, meaning slash, to the home controller's index action. This will override that default when we first went to just the slash or the root route of showing that welcome page, the one that said, welcome to Rails. Yeah.
Is this where you can also define what the pretty link should look like?
Yeah. So this is where we would define all of our routing. It will happen in this file. We'll get into it in much more detail. Right now, all I'm doing is mapping slash, or local host 3000 slash, to the home controller's index action. So mapping the root. If at any time I want to know what all of my routes are and what they look like, I can run Rails routes from the command prompt, and I will be told what all of my application routes are, what they're named. In this case, we have one named root. The HTTP verb that will trigger them, in this case a GET request, the URL, in this case just slash, and then which controller and which action gets executed. So that's what I wanted. And so if everything is wired up correctly, I should be able to now hit my server at just the root, giving it a moment to, it's sort of picking up on the fact that some files haven't yet been cached, so it's going to run those. The first time you typically load it up, it's a little bit slower than it will be afterwards. And there it is. Welcome to our Pokedex. This is a paragraph. That's the HTML I wrote in my view. If I view source, you can see that that HTML was injected inside of the body, inside of the layout. That works as well. So the very last thing I want to do is just to get the model involved here, just to demonstrate that from my controller, I can query the model and have that data returned to the controller, handed off to the view, and displayed to the end user. So in my home controller here, I can load up Pokemon by going to my Pokemon model.all. Notice, unlike when we were working with Active Record outside of Ruby, I don't have to tell Active Record to load itself up. There's none of that ar.rb file My models are all just accessible from within my controller without me doing anything. All of the models in the app models folder are just auto-loaded. And then here I'm assigning, this is very important, I'm assigning it to an instance variable, so an @var. Instance variables, or @vars, within actions are auto-magically shared with the view. That is, you'll hear that term thrown around a lot in the Rails world. Rails does things auto-magically for you. Here, Rails is completely blowing apart the idea of object-oriented encapsulation, right? Ordinarily, our instance variables are private and encapsulated within an object. Here, the convention is that if we create an instance variable in an action, it will be shared in the view. So over here in the view, I can say there are Pokemon.count Pokemon in our Pokedex. So notice this is similar to embedded PHP. This is an echo statement. So in PHP we did like less than question mark equals. Now we're doing less than % equals. And I am echoing out the count of that shared @Pokemon variable. If I head back over to my page here, there are 2 Pokemon in our Pokédex. I've got a little glitch in that I didn't properly close my paragraph tag, so I could do that. And that sort of, that wraps up the overview, right? We could also look at the entire, we could debug the Pokemon.first if we wanted to look at one of said Pokemon. And we get a little bit of debugging information about that particular thing. Not super helpful here, but you can see there's my name and my, my hit points. And so the last thing for me to do is to do like a final git commit. Git add dot and git commit. The index action is now loading all Pokemon, and the count is being displayed in the view. So thank you very much for coming to class today, and I will continue this demo next class.